Take it away.
Okay. Hello. Welcome. Thanks for having me today. Thanks for being here. I am Akif, Mehmet Akif Tutuncu. I am a senior developer here at IO. And as a consultant, I work at Rabobank. Today, I want to talk to you about one feature of Kotlin programming language, which is properties. And in this talk today, in this presentation, I'd like to try and answer these 4 questions. And in the end, as part of the 4th answer, I'm going to demonstrate some examples from a tiny library that I just wrote recently. And yeah, let's begin. But before I begin, I'd also like to get your opinion. What do you think immediately when I say property? Like what comes to your mind?
Fields of a class.
Yeah, that's good. Any other definition? Any other thing that comes to your mind? Yeah, that's also nice.
Application of properties.
Yeah, that's exactly what my wife said yesterday when I practiced. So that's another thing. Yeah, so let's continue. What I like to show when I mean a property is actually a combination of these 5 things. When you mean a property, you usually mean a property of something. Right, and in the object-oriented programming languages such as Java and Kotlin that we are dealing with, it is a property of an object almost all the time, and it also consists of these 5 attributes. We do give that property a name. We call it by something. We usually, I think all the time, define some sort of variable because it holds some data eventually. We do have a way to give it an initial value or construct it in some way. And we do have ways to access those values, like get those and update those values, replace them with new values by setting them. And this is all about encapsulation. I'm not going to go back to the times when we were all learning how to program and what object-oriented programming is, but the idea is encapsulation. That type, that object owns the information about what, how, and any other adjectives, adverbs you can put there, that property is. So here is the most verbose example of a property of name property of a developer. And because it is verbose, it is in Java. And I'm going to point at certain things here. So we mentioned we assign a name to it, right? We call it by something, and we define a variable. Oops, that was fast. We assign a variable. We have a way to give it an initial value, a way to construct it as a constructor in Java, a way to access that value as a getter method, and a way to update that value as a setter, right? So assuming that developer class, this is how we would use that. We would create a new developer object, and by the means of constructor and constructor parameter, we would give it its initial value. And when we want to access that value, we call the getter method, which prints out the name. By the setter method, we would be able to update the value, and we would then see the updated value. I am talking about mutable properties, things that are allowed to be changed, by the way. So what about Kotlin? Well, We saw it before, but that whole thing is just one line in Kotlin. This is concise, obviously, but I will also mention two other attributes of this. That is, properties in Kotlin are customizable. This means, well, it doesn't mean you cannot do those customizations in Java. It's just that it is also built in to the way it is designed in Kotlin, so that you are still defining a property. You are not really doing something else, but you can have custom behavior. And more importantly, that's kind of the root point of the presentation today, they are delegable. You can customize behavior and, well, delegate, hand it over to some other object so that you can do even more advanced stuff with this. And how we would use such a property in Kotlin is, well, simpler, because we are not, even though technically we are not really calling methods. We are just accessing one property of an object. It's like d.name is the name property of that d object, which is of type developer. And this is nice for getters, but it's even nicer for setters, because technically we are assigning a new value to something. So we say d.name equals. So this is the expanded version of how you would define a property in Kotlin. It's still a property, therefore it still has these 5 attributes, right? We still assign a name to this thing. This is something logical, by the way. That's why I highlighted the thing in the comments. We called it name. We do have a variable still. It's defined with the keyword var because we want this to be mutable, and it is a variable with the type definition. The initial value and the constructor are kind of separated. Initial value is, as you would expect, at a variable declaration, with just equals and then the initial value. The constructor, because it is embedded in the class definition as the primary constructor, has a parameter that we can refer to in the initial value of the variable. Getters and setters are also, they have this special sort of syntax. They are functions still, but they are attached as their syntax. They are attached to this variable. We immediately after the variable declaration, we are allowed to write a get and a set function like this, and Kotlin treats these as getters and setters. Because they are functions, you can do custom stuff here. And a cool thing is Kotlin gives you this magic keyword field to actually refer to the backing variable, that's what it's called, in this property. So a name property of type string would actually have a string variable behind the scenes, and you are allowed to access that variable with the word field here. I can return the value of that field. I can assign a new value to that variable field if this is a var property. So, okay, that's cool. We also saw how this can help with the customization, but what about delegation, the important part that I want to talk about? So, as I mentioned briefly before, Kotlin lets you delegate, hand over the responsibility of getting a value of a property and updating the value of that property to another object. And because it allows this, they also included many like built-in delegate object. The object that you are delegating to is called delegate, and there are some built-in delegates, and I think the most common one would be lazy. So I prepared an example of that here, but there are others like observable, map, I think non-null, and I don't remember now, but there are more, and you can find them on the Kotlin language website, linked there. Here is the example of lazy delegate, and also how you would define delegation. You define delegation by the keyword by. So you start defining your property, but then when you say by this object, what Kotlin does is delegates the responsibility to that object, but in this particular case, lazy is such a delegate that it doesn't evaluate the value until you call it for the first time. It makes initialization of a property, a value, a variable, lazy. And in this case, to be able to demonstrate that laziness, I included a println statement, which is something that's side effecting. So yes, this is a function. The thing that we are passing to lazy is a lambda, a function, and that function needs to be evaluated to produce the value, the string that says, hello, I am blah, blah. And because I am using the lazy delegate here, that evaluation never happens until I call that property for the first time. So let's go over the example. This is still a developer class. It takes one constructor parameter for the name of the developer, and it creates this greeting property, some sort of message that developer greets you with, and it is a lazy delegate. So normally, if you did not have that by lazy there and think of this like the initial value of that thing, you would expect this to be evaluated when the class, an object of that class is created, and that therefore something to be printed. But no, I create a developer, nothing happens. If I never call d.greeting, nothing will ever happen. But when I call it for the first time, this block is evaluated, and I get the message initializing in the console printed. Then I get the evaluated string value, but the second time I call this, it's not evaluated again, because that's how lazy works. This actually requires some additional work, some advanced stuff, other than just like giving something an initial value, right? So that advanced logic is moved into something else. It's called lazy, and Kotlin provides us with this helper function directly without any imports or anything, so that we are allowed to build lazy delegates. Clear so far? Please stop me if you have any questions.
I have a question. So
yeah.
How do I see from this code that only the print line initializing is not is lazy, that only that part is executable?
Yeah, because what you need to do for delegation is to give it an object that implements certain interfaces, which will come in a few slides. And the thing I am doing here is calling the function called lazy, which takes a lambda argument from, expects a lambda argument from me. And it is also generic in its definition, so that whatever that lambda is returning, it's actually giving me the lazy delegate implementation object of that type, of that generic type. So what's happening here is that I am calling lazy, I am giving it a lambda that produces a string, therefore I don't explicitly give it the type argument of string. Kotlin is able to infer this from the context, and this entire part of the code is actually giving me an object of that delegate, something that implements that delegation. So yes, you need to know that there is such a thing called lazy and how that behaves, but that's what's happening here. Moving on. Yeah, as I was saying, you need an object, and that object needs to conform to these types. What I mean is there is a read-only property and there is a read-write property, because we have vals and vars. Val is the read-only property that can only get a value after it's initialized, and var is a property that can get a value, also can set a value. So Kotlin provides these two interfaces, which are also like inherited read-write property extends the read-only property by adding it set value method. And the interesting thing here is that I'd like to point out is this property parameter of these get value and set value methods that these define. What that property is something that comes from Kotlin's reflect package, and it actually gives you additional information about the particular property, particular variable that you are being delegated from. I know that sounds weird, but here's an example. Knowing all this, I wanted to write my custom delegate, right? And I wanted something called, logged name, because why not? When I want some kind of property delegate object that gives me updates on the console whenever I'm accessing its value or whenever I'm updating its value, right? So what I did here is I created a class and implemented this interface, read-write property of any and string. This is designed this way so that you also get the reference of the enclosing type in the in parameter. I'm not focusing too much on that, but that's what it is. And when you don't care about the enclosing type, you can just pass it any. If I said developer instead of any here, I wouldn't be able to use this property object in any other class than developer. So it's actually really flexible, but depends on your use case. Because I said any for the enclosing type, like the owner type, and I said string for the actual property type, I am allowed to use this logged name objects in any class that I want for string typed properties. And the implementation is sort of straightforward. What I am doing here is I am implementing the methods that interface brings, and I'm just adding println statements because that's what I want for this object to do. And I am making use of the K property value here, like the value of type K property. There is name inside, and there are much more information available about the property itself. And this property would receive additional information about this value here. Name would give me the name. You can access the type, you can access the modifiers and more stuff. And for the setter part, you are also given the new value that you are being assigned to, right? So you can, I don't know, choose to reject that value by performing some validations. You can log like this. You can modify it like this. You can perfectly write a delegate for an integer property that just doubles the value that you are trying to assign to it. Because why not, right? So having this, I wanted this developer class modified a bit so that I am actually delegating this name property, delegating the logic of that property to this logged name object. This is a new object creation here. Kotlin doesn't have the keyword new. I am instantiating an object here. And what happens is I create a developer object, an instance of this object, and whenever I'm accessing the name property, I have a print statement to the console. And it's also mentioning the name. Maybe I overused the word name. I should have picked something else, but why? Name made sense. And also the same happens for the setter case, right? So, okay, this is more or less how delegation works. Any questions here?
Just to be sure I understand this correctly, the K property there is similar to the field that you would see in Java Reflection?
Yes,
and
that's
then
true.
The star there, is that like a placeholder for the type?
Yeah, exactly. It is the placeholder for the type. I think for the reasons of type erasure, if I am correct, the definition of the K property parameter in these methods are written like this. They just don't care about the value inside the type of argument inside the K property type. But yes, that's exactly what it is. I mean, if this is a K property of a string, it would mean that this is this is belonging to a property of type string. Yeah. For the purposes of the definition of that interface or the implementation here, I don't really care much about that type anyways. But it is a container that holds information about that field and that property in general. In Java, the counterpart would be field from the reflect, yeah.
And star would be question mark, right?
In Java syntax, yeah. Okay, so let's move on. I built something called periodic, and that's why I'm here today, to talk to you about this. What this is a delegate. I developed something that you can use as a delegate when you want that property to regularly update its value, its own value. And I built some customizable DSL, so to say, around this. The library has a lot of options to customize the behavior. The key point is that this is a delegate and it provides periodic updates. The name is written with a K because that's what happens in Kotlin library ecosystem. The key thing is that it updates periodically. It can be made lazy, so you can technically implement a lazily initializing value with this, but it would still also have the ability to reload itself. There are more customizations to how it initializes, how it logs things internally, how it blocks, because this supports coroutines as well. And as a simple use case, here is how you can build one. You create this object with the provided periodic function, just like how you do with the lazy case that is built in. So you call periodic function to start building this. You provide a value that's called schedule, to define how that periodic reload should happen. The current implementation is really basic, that just gives you the ability to do something every certain duration. But yesterday I attended a meetup that talked about the famous arrow library's schedule function, which is far more advanced than this. And that is my next idea, to integrate this with arrow schedule. Then you can do even crazier stuff like, I don't know, retrying, repeating on even more customizable intervals. I don't know. I need to see, but the possibilities are much higher than what you can do with the built-in schedule type here. But that's the idea. You build a periodic, you give it some schedule. You can do further customizations, which I will show you. But then when you say, well, build this thing, you need to provide a way to load that value. Just like how we did to the lazy, you need to provide a way to load the value. But because this is a refreshing thing, because this is a periodically refreshing thing, the API of this provides the previous value as a nullable type, nullable value as the input of that lambda. So here I get access to the previous, and the loading logic of this is also depending on it. So if I don't have a previous value, meaning that I'm loading for the first time, I am saying, hey, hello. Otherwise, I am giving it a value with like hello again, and then a timestamp. I included timestamp in the example because I wanted to demonstrate that this is reloading, right? So I created a developer. It's fine. When I access it for the first time, I get the first value that gets evaluated for the value of this property, which is hello message. Half a second later, before the schedule of this, before the schedule I configured is there, I still get the same message. So technically, this is also caching the value, right? And 3 seconds later, if I call it again, it would have been updated already, and I get another message with the timestamp of that time when it was updated. So that's the idea. And now I will go back to my IDE here. By the way, this is on GitHub, and this is published on Maven. So you are actually able to now add this to your project and use, which I will show. And let's go to the example. I have a Spring Boot application with Kotlin for getting some exchange rates, right? Let me show the controller. So it just has one endpoint. When you call exchange rates from two currency values, this gets me to the rates service, which has two dependencies, currency repository and rate API. Rate API is meant to be an external service, something like, I don't know, Fixer.io, because in one of the previous examples, I used Fixer.io for this, but for now, for the purpose of this example, these are both like dummy stuff, because the currency repository is actually just returning a predefined set of currencies for me. It is a synchronous API, not blocking, but could be blocking. It's just giving me a set. And the rate API is an asynchronous API. And it provides a suspending function for getting the rates of a given currency. So it returns a map with the exchange rates of the target currencies, basically. So I give it euros, and it gives me the exchange rates from euros to those currencies. And to simulate, I'm just delaying for 300 millis. Yeah, so that's the idea. What I want this application and this service to do is to, well, get the exchange rate from the source to the target, right? So I pass the currencies I extract from the path to my get method here, and some form of validation is happening. I'm checking whether given things are actual valid currencies. I'm checking whether they're the same, because then I really don't need to calculate anything. I could just return one. And if that's not the case, I load the rates map, which I showed you in the rates API, for the currency from. And then if I get a value, I get the currency to from that map, because I get the rates euro, all rates for the euro, then I get the rate for the USD from it, which gives me a double. But all are null safe here, as we mentioned earlier. So if all exist, I build this exchange rate object with the from and to and the exchange rate that I just extracted. Really straightforward logic, right? But what this rates is up to us to define, right? And I have the dependencies I want. And to load all of these every time would be one option. But what I want to do is for this application to actually cache the values, because for a certain duration, it's really a good idea to cache these, right? But I also want to periodically refresh this. It would be a good idea if I can have something like that, right? Well, lucky for you, I implemented that loading logic using the rates API and the currency repository here, and it's just doing a bunch of calculations, because it's first loading like all the possible currencies there are, then loading all the maps of exchange rates for all of those and just collecting them all together, etc. But because the rates API is asynchronous, there's coroutine work involved here, there's async work involved here. This may not be the best coroutine code out there, but it does the work. And this is suspend, right? So now, how should we define this as a delegate? Let's start by delegate. Anybody wants to help me?
Periodic.
Yeah? Cool. So what this gave me currently is an error, because it's saying, this is giving me something called periodic builder, which doesn't have a method get value. See? Because this is a val, when I am trying to delegate to an object, Kotlin expects that object to have that get value method that the read-only property defines. But I don't have that here because, and this is what I wanted to come to, that's the way I designed the library. The periodic function that you're calling is actually giving you something called periodic builder, because I want to have customizations before you actually build that delegate object. I introduced such a type, and it just gives you some sane default values. What happens is that, well, for scheduling stuff, periodic implementation needs the current time, current instant, and I am giving it away to load that now instant. I can include this in my definition so that I can wire up some external dependencies for this. Like I could give it a clock maybe so that I can replace that clock in my tests so I can do stuff. I am adjusting the value that I read from my current instant so that I'm able to modify time in a way that I can adjust my schedule. This will probably be less useful when there is an integration with the arrow schedule type, because that allows you to have more refined, I would say, schedules. But one use case I can think of for this is you could say, hey, reload this every day, but reload it at midnight. So you are allowed to modify the time that you are getting and set it up to some time you want. By default, it is giving this periodic object the dispatcher's default, which is a coroutine context, so that if a coroutine needs to block or suspend, it would be in that context. Again, maybe having a second look at how this library is utilizing coroutines would be a good idea. But again, this is something that does the job today. It configures it to log things to the standard output by default, and as default, it gives this initialization logic. It sets it to eager. So knowing this, now I at least understand why this is not happening, because what I'm getting is a periodic builder. I need to build this, and there are some options for me, right? Because eventually what I want to load here will come from that load rates function, which is a suspending function. I'm going to pick the build suspending variant here. This asks me for two parameters. The first one is the coroutine context, because you might want to switch the coroutine context you are giving to this when you know that you are going to block on certain things. So in fact, if we go to the definition again here, blocking on, not blocking on, sorry. Let's go to periodic builder and build suspending. The default value of that coroutine context given to this build suspending is actually switching that to dispatcher's IO, which is a better practice. So I can actually just leave it empty and give the next parameter as a lambda, which can be written in Kotlin as a separate block of code with the curly braces. If the last parameter of a function is a lambda, this is allowed. Normally, you would give the first value and then comma and the second value in Java, even if that is a lambda. But here, it's now asking me to provide a value. And as I said, it's also giving me the input, the last value as an input. So that's why I'm seeing a hint in my IDE as that the implicit it variable is actually that map, but as a nullable type. So I don't care about the old value now. I just want to call load rates. Now it seems to be compiling, right? Because what I ended up with this whole expression is now a periodic object of that map of string to double. This is fine, but we forgot to define the period. So I will say, well, do this every I don't know, every 1 hour, 5 seconds. This is something else that is nice in Kotlin. What I am passing it is something called duration, and it is coming from the standard library of Kotlin. And because of the beauty of extensions, well, I am able to call a method on an integer value, an integer literal for that matter, and it's converting that to a duration for me. See, it is defined as an extension. And every method is also coming from the library itself, which expects a Kotlin duration. So this is now good, but I want to do more stuff. What else can I do if I check the existing methods on this builder? Well, we did the on, we did the blocking on. We can provide it a way to know how to load the time. This is something I mentioned earlier. There's a shortcut of this. It actually has a variant that expects a clock so that it adjusts that other function of getting the time with using this clock. So maybe let's use this because I want my calculations done based on the UTC, right? And then, hey, I want to initialize this lazily because I don't want this rates to start loading when I initialize an object of service, which Spring will do for me because when it boots up, it will wire the dependencies, right? And my IDE is suggesting that because I'm using the default value, I am actually allowed to remove that parentheses. So that's also something nice. I can tell it to do certain logging operations the way I want. Like if I get an error, I can tell my periodic object to, like, this is the error message that happens, right? This error message comes from the implementation of periodic itself. And I don't know, I want to maybe print this to the error channel, right? And then this function is actually expecting nothing as a return type. This is by design of the library. In Kotlin, nothing is a special type so that it is actually a subtype of all the possible types, which means there is no way to provide a value of this type. Like of integer, there's a way to provide a value. You can give it 1, you can give it 0. There are values. There is no possible value of nothing type, which surprisingly corresponds to an exception being thrown because the program wouldn't be able to continue. And Kotlin is smart enough in many cases that if it sees the return type of something as nothing, it knows that program won't continue from that line. So with those smart casting features that we mentioned earlier, it is possible to do stuff. And inside in the implementation, it's actually doing this. That's why it's asking me to return nothing, also signaling to me that this should actually throw an exception here. And I would say throw illegal argument exception or illegal state exception is more suitable, right? And now IDE is complaining again, or rather suggesting something that this can be replaced with something else, or it's not doing that anyways, but you can say assert, which does the same thing. Anyways, I'll leave it like this. But yeah, you can do stuff like with the logging and the behavior of the periodic. There's a way to also just default all the logging behavior, which is happening by default if I'm not customizing it at all. And also, well, there is the initialized eagerly version of this, and for now that's it. But I also provided an SLF4J module and extension to the library, which gives me the ability to, well, just customize multiple things together so that logging happens with an SLF4J logger. And I just call this. And this is also provided as an extension. So that's the beauty of extensions, so that a different artifact, even something else that doesn't actually own this class, is able to add functionality to my object. If I go to the implementation of this in the real source code, you'll see that I am just providing an extension method like this that expects a logger from me. And if I don't provide it as a default value, it uses the logger of periodic class. So that debug kind of log messages are logged at debug level, other messages are logged at info level, error messages are logged at error level, and then the exception is thrown. So that's nice. But I could also provide it the logger I have for the service class here, so that anytime periodic wants to log something, it will actually log with the logger of this service, which is like dev, archive, exchange rates, etc. So yeah, that's pretty much what you can do with the periodic delegate. Let's also give this one a quick periodic thing, because it is much less likely that the supported currencies would change. I want to, I want to give this a schedule of maybe 1 day, right? And I am not customizing anything else. This can load eagerly because it's going to load once and then I'm going to forget about it. But this can also just use a synchronous function. So with this implementation, let's see if it is actually running. Okay, it is running. I think we had a way to increase the console font size. Console font. No. Anyways, is it visible? I can zoom in. Perfect. So after the app started, I see that there is a call to currency repository, and I see one log here saying, well, this periodic value has a new value because that's something that gets logged in the implementation. And it also mentions that this will be again at this point in time. And it's also saying that I am deferring the initialization of this periodic value, which is not known yet by the name because I haven't really worked with it yet. So it is logged as this. But when we know the name of the property, because it is accessed before, it is going to log it with the actual name here saying rates. This is the periodic of rates. And the app is running. Let's send it a request. I don't know if I can zoom in. HTTP 8080. And this is the exchange rates. Euros to Turkish liras, for example. If I send a request to this, after some simulated delay, I am getting a response with the exchange rate. And we see that things started happening. That is because from here on, it started logging that it is now loading the rates. It says that it is getting a new value because it wasn't initialized before. It got the value, and while getting the value, it logged certain things, that it's getting rates for this now, and that now, and that now, etc. And at this point, it has a new value. But because I set it to periodically update every 5 seconds, we will see this exact same message sometime later. In fact, if we wait enough, we keep seeing it because it's refreshing automatically. And if we are quick enough, we'll see that the same value is actually achieved because the value inside was cached. These are random exchange rates, obviously, but it is enough to demonstrate the fact that it is cached and it's refreshing automatically. So that's pretty much it. Thank you. Do you have any questions? All good? Yeah.
Question, maybe a bit internal thing, but how does the scheduler, what kind of trap tool does it work? You use the default dispatch or?
I am just launching a new async coroutine and global scope. Just the hackiest way I can think of, but yeah, it needs to be improved. And actually, let me see. I think I skipped over that part, which is, yeah. I actually never got to show you the actual implementation of the periodic type, right? So as promised, this is implementing the read-only property interface, but the periodic class itself is also generic in the way that lazy is generic and can be used for any type of properties, right? Because I want any type of properties to be useful here. Inside, I am keeping certain states in atomic references. Why atomic references? For concurrency safety mostly, but that's because I didn't really test all the cases, all the corner cases with the usage of coroutines yet. Just wanted to have also, they have the compare and set semantics in their APIs, and I am just making sure to use that to initialize something once when it is null, when I know it to be null. So the only core thing this has is actually implementing the get value from the interface of Kotlin, and I am setting the name of the property once I have access to it, as long as it wasn't set before, as I said. And I am currently doing like run blocking thing, which is, I know sounds hacky, but it was sort of necessary for this to work because, well, this is the interface Kotlin defines for properties, and it's not really accepting or returning a suspending function. There needs to be a point where I need to go from the suspending to the non-suspending. Yeah?
I mean, if you're blocking it, you're not suspending it, right?
Yeah, I mean, as I said, I haven't really tested all the scenarios, but I got this to work first. Then I plan on working on it to improve, especially around the use of coroutines. Because when I initially designed this with no coroutine support, everything works well as expected. But as soon as you start trying to introduce coroutines and suspending functions in that build function to accept a suspending function from outside world, well, you need to do something because this method definition itself has nothing really.
The builder accepts suspending functions because it's blocking.
Sorry?
The builder is accepting suspending functions because it's blocking.
Yeah, and to kind of remedy that, it's also getting coroutine context from you so that it's blocking something else and not.
I don't think dispatcher really matters here.
Yeah.
But you gave the default dispatcher, right? That's what I saw.
The default dispatcher is there unless you are changing it, and by using build suspending, you are automatically changing it to IO. Yeah.
Otherwise, there's a default. Default only has as many threads as you have cores, and when you have multiple of these scanners going on, then these threads, especially when you block now,
Yeah.
I would really use the IO dispatcher for that, because now I really have
Yeah, maybe it's a good idea to just default it to IO and just remove the possibility to change that, or still have it but default it to IO.
But again, it doesn't really matter here.
It matters in the sense that when you have a suspend method and you would do, for instance, asynchronous stuff concurrent.
Yeah, but it's not asynchronous here. It's blocking.
Yeah, but you still can do it coroutines. You could then two calls simultaneously.
Yeah, but,
And still have only one thread being blocked.
yes, but
That's the advantage.
but the builder is blocking.
Again, that is blocking. That's the interface, so you can work around.
You know, the context doesn't really matter here, does it? If you call it from a thread, the thread is blocked. The context you're giving, the blocking function doesn't
Yeah, but
matter.
what you do within run blocking can be something concurrent or something parallel.
Yeah.
In the blocking.
Yeah, of course, yeah. Only the calling thread would be blocked, but what you do within run blocking, you can do a lot of asynchronous stuff. You can call 10 services simultaneously, but they wouldn't block. Only the call to run blocking will. Okay, maybe we can take it to the break.
Yeah, and in within the run blocking, this is what gets run, like get if needed, which does some checks with the internal state to see whether it should actually load it again by just doing some instant calculations. And as you see, there are certain places where this logs stuff or calls error, and that's the thing with nothing. So I am calling error here, which returns nothing. And Kotlin knows that if it arrives here, it won't ever evaluate the rest of the code. So it can be smart about things. And that's exactly why when I use last instant here, it is non-nullable. It's instant directly, but the thing I'm getting from the atomic reference of last get instant is actually instant nullable. It did a smart cast there because it passed the case where it returned nothing. So a check to see if we can reuse the value, and the actual get, which happens if we cannot reuse the value because it doesn't exist or it expired, is this. It's just updating the internal state. It's calling the next value function, which is the function you are passing to that build argument to get the value, calculates when it should have the next value, and then as a hacky scheduler thing, it's just letting loose one async coroutine that starts, that will eventually call the same get again. Can this be better? Yes, of course, but this works so far. And that, yeah.
About the library itself.
Yeah.
It seems like the concern of signing this result or managing the periodic doing of stuff.
Yeah.
And assigning it back to the value where you're attaching to, you bind it to. It does not necessitate having all this. It seems like it's a periodic scheduling library.
Yeah.
With a use case to bind it to a variable.
Yeah.
But shouldn't these two be two separate things?
It's perfectly reasonable to have those as separate things.
Scheduling library and then a bridge to bind it to
Yeah.
a variable.
But that's when integrating with a more powerful scheduling library would come in handy. I would actually keep the scheduling part out of periodic itself, but if you would prefer to have that scheduling ability elsewhere, you would be able to do that. And that's actually what the SLF4J module is demonstrating, that it is really possible to just externalize stuff. Yeah. Another reminder that this is on my GitHub. The slides and everything will be shared, of course. It is released, as I said. You are able to even see like KDocs online, which is cool. You can go to the readmes of individual modules to see how you would include it in your project, just like any other dependency that you have. And there's the minor small example here. And that's all. This is open source. Contribute. You're welcome to do so. And thank you for listening to me.
Thank you, Akif. We have something, of course, for both Earth and you.
And yeah, akif.dev is my website. I have lots of options to contact me there.
This one's for you.
Thank you very much.
Thank you. There you go.
Thanks a lot.
Thanks for the talks. And stick around, guys.
Let's do a selfie.
Yeah, sure.
Good night.